Hi everyone, welcome back to the channel. Today we're having a quick look at a carbon rim that's failed. Now this wheel actually was given to me by a friend who wanted a rebuild. He said there was some vibration in the brake track, so I looked at it. As soon as I looked at it, I noticed it was massively warped around a lot of the brake track. So what I do, I told him to stop riding it and we cut it up to see what's happening inside basically. So here's a video of me cutting it. Now, interestingly, the first thing I noticed when I was cutting it is as soon as I made the first cut, the rim really did like snap open. Now, what does that tell you? Well, there was a lot of kind of residual stress in the hoop of the rim after curing, probably. So after it's cured, there's a lot of kind of captured stress inside of that hard rim, probably due to mold shrinkage. And as soon as I cut into it, bang, it snapped apart quite a lot. You can kind of see that here. So I carried on cutting it, cut it in a few places where the warping was the worst on the sidewall by the brake track. This is probably the worst bit of the rim that's warped, and you can see basically what's happened is the epoxy in the pre-preg has got too hot. It's gone towards the glass transition temperature, and we'll talk what that is in a minute, and the pressure from the tyre has exerted a side load on the sidewall, and it's just bulged out the brake track, where the epoxy here locally has got very soft because of the heat build-up. Now ignore this kind of rough looking stuff in the middle. That's actually the bag from the moulding process, and generally in frames and wheels it's kind of hard to get that out, so sometimes they just leave it in. Now more up-to-date carbon wheels don't use the bag in here. They use like a foam core, which then shrinks in the curing process, and they can pull that out. That's called EPS, or expanded polystyrene, and this is kind of an old school method of doing it with the nylon bag. I don't actually know what kind of plastic it is, but I mean the inside of it looks okay, and there's no, for all the sections I cut, there's no major voids or pores in the laminate, and the laminate is quite well compacted. It's just, it's got too hot. So I'm not dissing the quality of this rim, and actually I don't know. It's an unbranded carbon wheel. I don't know where it was sourced from, but the compaction and the laminate quality is pretty good. It's just got too hot, and that is a problem with carbon clinchers. Now we'll discuss why that's a problem with carbon clinchers and not such a problem with tubs in a minute with a little diagram. But yeah, I mean, this is like a 35mm deep rim. It's quite a nice quality. There's no obvious bad features in the layout. It's good compaction, like I said. Now there's a slightly weird feature to the layout in that it's not so obvious on this camera, and that's a bit more obvious where they put the thicker laminate for, or more layers in the laminate for the spoke bed. It's kind of, it looks like on this it's slipped in the mold, and this thicker area is over to this side, and it should really be in the middle, because this doesn't have offset drillings for the spokes. The drillings are all in the middle, but it looks like the thicker portion of the spoke bed laminate has moved in the mold to one side, and I don't know if that's on purpose. Now if they've done that on purpose, that's pretty cool, because you do actually have different, because of the spoke angles on the drive side and the non-drive side being different. Well, the drive side has a lot straighter spoke angle, and the non-drive side has a more of a horizontal component to the force. So whether they've done that on purpose, I don't know. If they have, that's a really nice touch, but that's giving them the benefit of the doubt. I doubt they have done that on purpose. But yeah, apart from that, that's kind of a normal structure. Now this is a tubeless ready wheel, because it's got this extra groove in the middle to help you mounting the tubeless tyres. That's not such a problem. So if you're choosing a carbon clincher and you're worried about having that extra groove in the middle, that's not a massive problem. It doesn't increase the stiffness massively. But what I'm about to say is, you really do need to think twice about whether you want a carbon clincher or not, because the structure of them is inherently flawed. Especially when you're making it out of carbon, all because of the epoxy TG temperature, which is the glass transition temperature, which is where the epoxy loses its kind of stiff glassy properties and starts going floppy, and it loses a lot of stiffness very quickly above around 120 degrees. Now you can get higher quality resins or heat resistance resins which push the glass temperature more towards 180, which is a very expensive resin. But I can tell you now, the wheel builders, the wheel factories don't use those very expensive resins. So let's just recap why this has happened. The rim has got too hot due to braking, the epoxy has gone soft, and the force exerted by the tyre pressure on this sidewall has just pushed it out. Now, like I said, I do ride carbon clinchers, and yeah, I'm not dissing them. I do ride them, but I only ride them really if it's flat, because I don't like, I'm really heavy, and the heat in the brake track when you're braking like down a hill goes up linearly with mass, and it actually goes up with a square of speed. It's basically kinetic energy transfer into heat energy. It goes up with a square of speed and linearly with mass. So if you're heavier and you're braking from the same speed down a hill, you're going to put more heat into the same rim as a lighter rider was. But like I said, this guy was only like 65 kilos, and he's managed to do this bad damage pretty easily. And he can't even, I don't think he can even realise when it happened. It wasn't like a particularly steep hill, but he was so lucky that the tyre, you know, when this hook has opened up, he's very lucky that the clincher, the bead of the tyre hasn't just popped out and the tyres come off whilst riding, and that would be really dangerous. So what I'm about to say, well, I really don't advise riding carbon wheels in big mountains and big descents because of this problem, and it all comes back to the epoxy. It's not a great, it's a thermal insulator. It's a really bad material to make a brake track out of, and that's as simple as that. Now, Shimano don't make a full carbon clincher for a rim brake, and it's because of this. They've just said, you know, fundamentally it's this section, this kind of C section is an open section, so it's unsupported at the top. If there's any side load here and this gets soft, it will just bow out. So Shimano is one of the companies that only do carbon rim brake wheels in tubular format, and I'll get to why that's better. Now, some of you good people who follow the Peak Talk douchebaggram have picked up on this in the comments. Now, you're bang on. Tubulars are more stable to ride because of their structure than the clinchers, if you're going to do big mountains and they're going to get hot. Now, why is that? Well, let's have a little look. Well, let me adjust the... Right, sorry about that. I've just adjusted the aperture on the camera so we're not blown out. So here's the clincher. Oh no, it's too dark for the clincher. Okay, here's the clincher structure. So you've got this open, unsupported area at the top, which can be blown out by the tyre pressure. If you've got 110 psi inside here, it will just push out on the sidewall. And if this gets soft, it'll bend out like this has. Now, the tubular is inherently a better structure because the top of the brake track is tied together by this member here, which is on the clincher, this part. In the clincher, it's completely unsupported. So even if you do get a bit of softening in the epoxy next to the brake pads in the tubular, it's a stronger structure. It's tight. It's a closed structure, so it's much stiffer. Secondly, now arguably in the tubular, the tyre pressure does not actually exert a side load on the brake wall like it does in the clincher, because the tyre is basically bonded onto this surface here and not enclosed by it. If the tyre pressure increases, or the tyre the stable tyre pressure anyway, it doesn't really put a side load into the brake track, so you're not asking it to do that extra job like the clincher wheel is, and that's why the tubular is a safer option if you have to ride rim brake carbon wheels, which arguably I don't advise anyway. The tubular is a stronger option because it's just better supported. It's better supported in the compression from the brake pads. So when the brake pads are pushing inwards, it's better supported because they're generally tied together here. And if there is any outwards force exerted by the tyre, now arguably there isn't, because the tyre pressure on the clincher acts out on the brake track, whereas on the tubular it acts mainly up and down. So you've got a hoop stress going this way and this way from when you inflate the tyre after it's been glued on. It doesn't actually impart much side load on the brake wall. So the tubular is a much safer and stiffer structure, and obviously That's probably why Shimano only make like the Dura Ace carbon wheel in a tubular version. If you want to buy it in the clincher version, actually it's an aluminium box section rim, which is a lot safer, with a carbon fairing. They don't do a full carbon clincher rim brake, and that's, you know, I kind of trust Shimano, and that's why they've done that, because they know that this inherently is flawed shape. Now, what do I mean by TG temperature? Well, the TG temperature, like I said, is the point at which the resin really starts to lose its stiffness. And for most basic pre-preg resins that would be used in something like this, you're looking at around 120. Much higher end heat resistant resin, you can get up to about 150 or even 180, but they are quite expensive and probably not used so much in the bike industry. Now, if you take a quick look on a graph, if the stiffness of the resin is on this axis and the temperature is on this axis, this is the area where you want to operate, and the resin is quite hard and glassy. After about 120 in a basic resin, it really starts to lose stiffness, and this is kind of probably the temperature here where this has got to, and it's failed. Now go really high, kind of beyond 200 or 250, and you basically end up with a viscous liquid again. Even though the epoxy is a thermosetting polymer, if you get it really hot, it will kind of go viscous. Now, I'm not saying we've got up to this temperature, but even if you get to say 100, your slope is kind of tending downwards, and you get to this big transition area where you lose a lot of the stiffness in the sidewall, and you really are at the mercy of, is the tyre going to pop off or not? Now, hopefully in this case it didn't, and we caught it just in time. But what I'm saying is, these are kind of flawed structures, so if you use carbon clinchers, just be careful basically. Don't bomb down hills and jam the brakes on from high speeds if you can avoid it. Now, I know that sounds stupid because you should be able to brake as hard as you like, which is kind of why I ride disc brakes now, but I only use carbon clinchers really for flat rides or short descents, or on the TT bike where barely you're braking anyway. So in that respect, you know, they're completely safe, but you really should think twice about the scenarios when you use your carbon clinchers basically. So thanks everyone for coming back. I do actually have another video coming up soon, which this is a kind of lead-in for, which is about why carbon is not the amazing wonder material people often think it is, particularly in the bike industry, and that's going to be quite a lengthy technical discussion on properties of carbon laminates. And if you're interested, it's going to be pretty detailed, that one. Stick around for that. That'll be up hopefully in a couple of days. But yeah, think twice about using these. If you want to really use carbon wheels, try tubs if you're going to do big mountains. Cheers.